What I want to talk to you about for the next couple of minutes is higher order flow control in JavaScript. And when I heard about this conference, I knew that there were going to be people from a lot of different backgrounds. I myself originally come from a .NET background. I'm kind of an expat from the .NET kingdom. And for the past year or so, I've been focusing a lot more on writing JavaScript applications. How many people here write in a language other than JavaScript at least half time? All right, so almost everybody. So one of the things that tripped me up a little bit coming to JavaScript server-side applications, and I know it trips a lot of people up, is what are all of these callbacks doing everywhere? How do I deal with non-blocking I/O? I understand kind of some of the benefits conceptually, but this doesn't look like the code I'm used to writing. So what I hope to do today is go over some of the concepts and hopefully provide a little bit of a bridge to show you some really good techniques. Now, I'm going to stick mostly at the conceptual level. There's a lot of really great implementations of these things out there, but these are what promises are and what you can do with them in JavaScript. So how many of you have the latest iDevice from, yeah, great, the iPhone. Now they have like the iPad 18 or something just came out. This is really inefficient. This is a lot of people lining up for something that I think the iPad mini doesn't even go on sale until the first part of November or something. That's really dumb. And when our applications do that, that's even worse. Our applications should be a lot smarter. But traditionally, you might have a thread spun up for every single web request that you have coming in that your application is going to handle. And that works well, but you quickly run into the limit of your thread pool in whatever application server you're using, whether it's IIS or anything else. And what that means is that new requests that come in are either ignored or they have to wait at the end of this really long line. So even if your application isn't CPU bound or I/O bound directly, you still have this really inefficient horizontal scaling as you basically are forcing people to do this. So Node solves that, I guess, by having a very asynchronous manner of I/O and programming model by default. But that introduces a whole other array of issues. What promises let you do is basically you get a token, a guarantee, if you will, for a value in the future. So this way, when I go into a restaurant, I don't have to wait in line. I get to go and enjoy a beverage or check my email or do whatever else, and I have a physical token that I could hold on to and carry around that will let me know whenever my table is ready. A promise is like an IOU. It represents a certain particular type of value that you'll have in the future. So in Node, you might go and you might open up a request. It might be a file read request. It might be I/O over the network, reading off of a REST API, for example. And typically what you'll do is you'll pass it a callback, right? You'll give it the function that is going to act as the continuation that will be able to operate on whatever data is coming back. But does that seem upside down to anyone? I'm having to give my function off to some third-party API to do whatever with. With promises, you get the direction of control back into your application domain. So rather than having to give a function, a continuation, to the file system API, for example, the file system API gives me an IOU saying, we're going to give you your file stream as soon as we're able to open it up and get that resource on disk available. And then after that, with the promise, I could attach whatever other functions and callbacks I need to onto that. And I get to retain control over how that happens and when that happens. This is a painting by a famous North American painter, Norman Rockwell, called Gossip. I guess this is how news used to travel before Twitter. Now we have retweets, so we have really high fidelity gossip, I guess. There's no mutation happening in between the different state transitions. But what's illustrated here is that once you have a token for this future value, you could string them together, and you could pass them through pipelines, and you could have functions that do things to these promises that return other promises. So suddenly what you have is you still get all the benefits of asynchronous programming in terms of being able to continue running your application and not block on I/O. But you have something that's a lot closer to a traditional programming model. Promises aren't about making your code look pretty. A lot of people come to promises because they see this rightward drift as you have all these nested callbacks. It's kind of a telltale code smell of a lot of beginning Node programmers, is you'll have a callback. Okay, well, this needs another callback, so I'm just going to inline it here, and another callback, and so pretty soon you're 10 or 20 layers deep. And I hope you're using two-space tabs, because otherwise that's going to be, screens and screens that you're having to scroll over horizontally just to try and see what your code does. The other option is you could define all of your functions separately along the left-hand side, and then it looks, I guess, like a Python program, and then kind of wire up all the callbacks at the bottom, and then your code is still kind of looped around inside out, and you're having to kind of like reverse read it backwards to be able to understand the actual flow of control in your application. So yeah, promises will make things look really pretty, but that's not why they're important. Let me see if I can make this a little bigger. Is that better? If it stays. So this is pseudocode, basically, for what a function might look like in the traditional synchronous programming model. You have a function that takes some parameters stuff. Maybe you have some sort of error checking within your function, some pathway through your function by which it will throw an error. Or the other way that the program flow can continue through this function is it can return a value. You could get more elaborate functions that have multiple returns. You could have early returns. You could throw different types of errors depending on whatever it is that your function is doing, whatever it makes sense to do. But basically, a function takes some values in, or maybe no parameters at all. It just takes an invocation, and then either returns a value or throws a value. And in JavaScript, you can throw anything. It doesn't have to just be a specific error or an exception class or something like that. So you get some stuff in, and you spit some stuff out. In asynchronous code, using promises, this is what that looks like. So we have a function that still takes some parameters, stuff. Instead of returning a value immediately, I'm returning an object, which is a promise object. Instead of using the throw keyword, when I have an error condition that I want to return from my function, it uses reject on the promise, and then takes whatever value you're rejecting the promise with. Or you're resolving the promise, which is equivalent to return. The syntax isn't really important because there are different implementations of promises in terms of the internals. This is an example that shows it kind of inlined as a function. You could also work in a more object-oriented manner where you do var promise equals new promise or something like that, and then you have a promise object that you would be calling reject or resolve on instead of this. But the important part is that with promises, you still have the same programming model that you have in a synchronous function. You take some stuff in, and you either return it, you resolve the value, or you throw and reject the promise. And that's important. Promises are stateful. They have a very simple state model. Just like a function, you have the function that's kind of just idle before it's been invoked. And in JavaScript, that's important because you could pass around functions as first-class objects. So a function object is basically like a pending promise. It's there. It'll eventually return something or throw something, but it doesn't have any value yet. Then once you call resolve, the promise is in a resolved state, or you call reject, and it's in a rejected state. And this is important because it guarantees that whatever callbacks you have handling these states will only ever be invoked once. A promise is finite. If anyone's interested in streaming stuff, I could talk about that offline afterwards with you. But promises are a very special case of a stream. They invoke their callbacks a single time based on the state of the promise. And so why is it important that I spend all the time going over the analogy between promises and traditional synchronous code? It's because we get a lot of the same properties that we get with synchronous code. In math, if you wanted to compose the function f of g of x, in traditional synchronous code, you just kind of compose them from the inside out. And this is what that equivalent looks like in promises. This says we're going to invoke g, which is a function that returns a promise. And as soon as that function is resolved, then we're going to take the resolved value of that promise and invoke f with the resolved value of the first promise. The then function, in turn, returns another promise, which is the value after f is called. So f here can be a function that returns a promise, or it can be a synchronous function. And in either case, the promise that's returned by then is going to be resolved with the value after f is done being evaluated. So we could get really long lines of thens. We could do all kinds of things, all kinds of really great functional composition, the same as you would do with synchronous code. And then the second great property, and this is where promises really have a lot of advantages, especially in real-world and production applications where error handling is important. Some advantages over the traditional continuation passing style that you might see in Node frequently. So let's say I have some sort of data access layer, a repository of users, and I want to get some users by ID. I want user number 2. And then I'm going to have my callback that is just going to log the user to the console. What do I do if there's an error? Well, that's easy. I'm just going to do whatever I need to. I'm going to add a message to it or something, and then I'm just going to throw the error that I got back from that, and it's going to be caught in my try-catch block. And does anyone see what I'm doing wrong here? So that catch block is never going to catch the error that's being thrown. It's going to throw where the callback is there. Yes. This gentleman said it's going to throw where the callback is invoked, which in Node is not necessarily going to be in place. In fact, very often, most of the time, it's going to be in a different tick of the event loop, and in which case you have no way of catching that with a traditional try-catch block. So what frequently happens is you would end up basically manually wiring up each function to bubble up those errors back up the chain if you're being diligent about it. And if not, you'll just be ignoring the errors and not having any sort of error handling and hoping that everything goes along happy path. With promises, the signature of then lets you specify a resolved callback as well as a rejected callback. And the rejected callback will be invoked when a promise is rejected, of course, when there's an error state. So you could do it in place here. And if this looks similar maybe to some of the jQuery APIs to anyone, it's because they sort of implement this, but don't kid yourself into thinking that they implement promises. They just say they do, but they really don't. So you're specifying two separate functions instead of one function that's dealing with both cases. And the reason why this is important is because in traditional error handling, you're not necessarily writing a try-catch block in every single function that you're writing. You have some more general error handling. You're catching errors and dealing with them top level. You're not necessarily having discrete error handling at each step along like a data access pipeline, for example. And with promises, you can do the same thing. So we could chain a bunch of stuff together. We're going to get our users, we're going to log it, we're going to do some sort of manipulation on it, we're going to save it. And then this last instance of then does not have a resolved callback on it at all. It's just adding a top-level error handling callback. So if there's an error anywhere along the ways, we're just going to log it to the console. And in this fashion, that will be invoked if there's an error anywhere along the chain. So if there's an error that happens in this manipulate data step, then the rest of it's not going to be invoked at all. It's just going to bounce the error right back out, and that'll be handled here. So now that we know a little bit about the properties of promises, I just want to play this real quick and see if it gets your brain thinking. Oh. This hotel has really great Wi-Fi, by the way. At a lot of conferences, you can't show videos. So we've got dominoes doing all these kinds of crazy things. They're set up in these really interesting arrangements. But the flow of the execution of this domino program keeps going the whole way. The only thing they need to agree upon is a common interface. Basically, gravity and the physics that says, when I knock into you, you're going to fall over in this direction and then do something. Yes, it is. So what I'll say is it's serial. A lot of these dominoes are set up in a series, but and here we have some error being thrown. Yes, exactly. So we have a lot of them that are set up in serial, but here's an example of where it forks off and we have two parallel processes going. We have multiple lines of dominoes happening at the same time. So what it lets you do is it lets you look at your business logic that you're modeling with promises, and it lets you parallelize the things that can be done in parallel or guarantee serial execution of things that need to happen in serial. And it makes it really trivial to move back and forth between things that can be spread out into parallel processes, maybe things that are thrown over to like maybe you want to implement a connection pool or something. If you want to make 1,000 API requests, but you don't want to totally hammer this other server, so you want to limit it to 8 concurrent requests, you can queue up a bunch of promises for something and then write some, this is where the title of the talk comes in, higher order stuff that will deal with the logic of executing them 8 at a time, for example. And then when they're all done, you could come back and continue your program wherever you need to do. So you could set up, in a very real sense, programming with promises is like taking the work to set up a really long chain of dominoes, and then based on the arrangement, you basically know what the program is going to do at any given time. Before you ever execute it, you can rearrange things. And then whenever you start executing the program, that's knocking over the first domino. And then the values of the dominoes, I guess, are just your promise returning functions. And then that'll propagate through the system to your normal course of flow control. And that's a really important property. It's not complex, but it's very profound. What it does is it lets you write your programs the way that they need to be written rather than the way that it's convenient to write them. If you have a bunch of stuff that can be done in parallel, it should be, but it should be no additional effort. There should be nothing in your programming model that's discouraging you from doing that. And if you try doing it in Node, for example, in straight continuation passing style, it's somewhat difficult. It's not the default option to do things in parallel. And you start getting into all these ways of wiring things up yourself, right? So let's say I have 10 requests that I'm making, or 1,000 requests. You could fire them all off, but then in your callback that you have, maybe you need to be accessing something that's sharing state. Maybe you have some var I equals the length of the number of requests I want to make. And then in the callbacks for each of the success handlers for the requests, you're decrementing I, and then you're checking to see if I got to 0, so that you know when all the requests are done so that you can continue doing something. Well, that's very tedious, and it's also a very bad separation of concerns because your handler for when you finish the requests should just be concerned about what it's doing with that request, not also keeping track of the flow state of your program. And using promise tokens, you could externalize all of this. And there's actually a bunch of really great libraries that can let you do some of these different like domino-style techniques of spreading flow and joining flow, waiting on a series of parallel tasks to finish before you could go on and resume doing a serial pipeline. Let's see if I could get back to here. So I started going into this. It's about writing clean code. It's about writing code that's not fragile, that you can have a whole team of people working on, and they only have to agree on a small common interface. It's about being able to write functions that care about one thing. I need X, I do Y. I take these parameters, I return these values. I don't care about keeping track of whatever other requests you might be making. Also, I don't care when I'm invoked or any other sort of stateful aspect of the program. There's a whole host of cross-cutting concerns that you could address with promises, and I'm running out of time, so come find me. I'm happy to talk about this, but here's some links, and make amazing things. These slides are up at that address, jden.us/JS.everywhere. So, all right, well, thank you very much.